The coplanar forces, this, act at a point this, find the magnitude and direction of the resultant, which is a clear indication that the forces are not in equilibrium. If tan alpha is 5 upon 12, Pythagoras theorem will give me this 13. So automatically sine alpha is 5 upon 13 and cos alpha is 12 upon 13. Why is it important to find sine alpha and cos alpha? Because whenever I resolve the forces, I get values in terms of sine alpha and cos alpha. So every time you are provided with an angle, if its angles in degrees, then you apply the calculator values of sine and cos. But if it is in ratio, then always find sine, cos, tan in ratios. Tan is not needed. Sine and cos in ratios are definitely very important. Is everyone following me? So what we'll do is, when I resolve this, this will become 26 cos alpha, and this will become 26 sine alpha. So 26 cos alpha is 24, and 26 sine alpha is 10. Now check the vertical forces. 58 is upward, 10 is downward, 48 newtons. Horizontal is 31 plus 24, 55 newtons. So now I have my horizontal forces and my vertical forces, both are coming out from the same point. This is 48, this is 55. I will apply parallelogram rule. This is 48, this is 55. And I will apply Pythagoras theorem. Hypotenuse square is 55 square plus 48 square, which is 73. I will find this angle. It is always advisable to give angle with the bearings until and unless सवाल ने बोला हो with the horizontal ने. तो इस सवाल ने कुछ स्पेसिफाई किया है, इस सवाल ने नहीं स्पेसिफाई किया, तो बेहतर है बेयरिंग की फॉर्म में देना. When the question does not specify, always give answers in it. If the question says with the horizontal, then give the horizontal. Degree में 48.9 degrees. Since it is bearing, so the resultant will be 73 newtons on the bearing 0, 48.9 degrees. Bearing is always in 3 digits before this. Is this clear? Three coplanar forces act at a point. The magnitude of the forces are 5.5 newtons, 6.8 newtons, 7.3 newtons, and the directions in which forces act are shown in the diagram. Given that the resultant of the three forces is in the same direction as 6.8 newtons. Resultant कह रहा है इस direction में है. अगर resultant horizontal है, तो इसका मतलब vertical equilibrium है. Are you all with me? If the movement is horizontal, vertical is equilibrium. If the movement is vertical, horizontal is equilibrium. Since there is a movement, it's a clear indication once again equilibrium conditions are not being applied. So horizontally equilibrium conditions are not being applied, vertically equilibrium conditions are prevailing. So I need to find alpha and magnitude of the resultant. So what I'll do is I'll resolve this force. This will be 7.3 cos alpha and this will be 7.3 sine alpha. Since it's a vertical equilibrium, 7.3 sine alpha is 5.5. Sine alpha is 5.5 upon 7.3. Sine alpha, alpha is sine inverse 5.5 upon 7.3, 48.9 degrees. Now, I will apply this on the vertical forces. 6.8 minus 6.8 is on the positive direction, minus 7.3 cos 48.9. And this turns out to be 2 newtons. Do you all agree? All right. Forces of magnitude 10 newtons and 8 newtons act in the direction as shown. Write down in terms of theta the component of the resultant of the two forces. Okay. So if I resolve, ये पैरेललोग्राम बन जाएगा, ये 8 है, ये 8 हो जाएगा, ये 10 है, ये 10 हो जाएगा, ये थीटा है तो ये थीटा हो जाएगा. This is 8 cos theta, this is 8 sin theta. Are you all with me? Parallel to 10 newtons, 10 minus 8 cos theta. Perpendicular to 10 newtons is 8 sin theta. Resultant के लिए sum of all horizontal is 0 and sum of all vertical is 0. Yes or no? The resultant of the two forces has magnitude 8 newtons. Cosine rule लगाऊंगा because I have this 8, I have this 8, I have this 10. A square is b square plus c square minus 2bc cos theta. 6400 plus 64 minus 2 into 10 into 8, 160 cos theta. Minus 100 minus 160 cos theta. Minus 100 minus 160 cos theta. Cos theta is 5 upon 8. Question 24 is broken into two parts. We'll do part by part. Four coplanar forces of magnitude 4 newtons, 8 newtons, 12 newtons and 16 newtons act at a point. The directions in which the forces act are shown in figure 1. Find the magnitude and direction of the resultant. Vertical force मेरे पास क्या क्या है, इसको रिजॉल्व करूंगा तो वर्टिकल फोर्स आएगी 12 sin 60. इसको रिजॉल्व करूंगा तो मेरे पास वर्टिकल फोर्स आएगी 8 sin 30. तो 16 प्लस 12 sin 60 प्लस 8 sin 30. Horizontal 4 12 cos 60 and 8 cos 60. 4 plus 8 cos 60, sorry, 8 cos 30 and 12 cos 60. 30.4, 9. So now I have vertical and the horizontal and I will apply 30.4. Apply parallelogram rule. 30.4, 16.9. Hypotenuse square is 16.9 square plus 30.4 square. 34.8 newtons. Angle बेरिंग की फॉर्म में बता देते हैं. Tan inverse of 16.9 upon 30.4. 29.1 degrees. Done? Clear? Understood? अब बोलता है find the magnitude and direction of the resultant of the four forces. अब हुआ क्या, अगर आप ऑब्जर्व करें तो सारी फोर्सेस उल्टी कर दी हैं. जो वर्टिकल है वो हॉरिजॉन्टल हो गया है, जो हॉरिजॉन्टल है वो वर्टिकल हो गया है, जो 60 डिग्री है वो 30 डिग्री बन गया, जो 30 डिग्री है वो 60 डिग्री बन गया. यस और नो? क्योंकि सारी चीजें उल्टी कर दी हैं तो जो रिजल्टेंट है वो सेम रहेगा, 34.8 ही रहेगा। And the angle with the bearing will be reversed. Alpha will be tan inverse of 30.4 upon 16.9. That is 60.9 degrees. हम बेरिंग के हिसाब से बता दें तो 60.9 डिग्री। ये 7 है, तो ये 7 साइन बीटा और ये 7 कॉस बीटा और ये W साइन अल्फा और ये W कॉस बीटा, W कॉस अल्फा। सो अपवर्ड फोर्स W cos alpha plus 7 cos beta is 0.6 is equals to 8. W cos alpha is 8 minus 4.2. W cos alpha is 3.8. 7 sin beta is W sin alpha. Sin beta is 0.8. 5.6 W sin alpha. Now W is 5.6 upon sin alpha and W is 3.8 upon cos alpha. So sin alpha upon cos alpha is 5.6 upon 3.8, 55.8 degrees. W भी निकाल लें, W is equals to 3.8 upon cos 55.8. 6.76.